My name is Keegan Justis, and this is a talk about building bulletproof AWS environments with secure CDK constructs. A little bit about me. I've worked as a cloud security engineer at GuidePoint Security. We're a full-service security consulting firm. I've been a DevSecOps engineer at several early-stage startups and started the security program from the ground up, all the way from idea to SOC 2 to live customers. Gone through several security audits. I have a bachelor's degree in management information systems from the local Washington State University, and I hold over a dozen active industry certifications, mostly in cloud and security. I guess I should give you a brief overview of security in the cloud, and then at the end I'll go over the code. Something that's really important to know is that there's a shared responsibility model in the cloud. This is not talked about enough. Their cloud providers are responsible for more of the physical security of the data centers, and then the customers are actually responsible for a lot of the configuration of their applications within the cloud. There's split duties, and it's important because you might be HIPAA compliant on paper. AWS may be HIPAA compliant, but if you want to become HIPAA compliant, there's actually additional steps that you have to do. There's partly cloud provider's responsibility and partly your responsibility. I'll give you a brief overview of the Cloud Security Alliance. They're a great platform, or they have some tools and standards for setting up cloud controls. They're highly recommended. They're an industry leader in determining controls for the cloud, but I'll touch on them very briefly. But when it comes to deploying the cloud, historically, before infrastructure as code, there was something called ClickOps, and it sounds exactly what you think it is. You go into the console, you click on, I want to launch an EC2 instance, I want to launch an RDS instance, and you do that. And it's good if you're just trying to set up something really simple, you don't really care about security, and you just need it really fast, and you don't need to reproduce it. But if you try to get specific configuration, you have to do it repeatedly. It becomes very easy to make an error. They even say it becomes exponential the more things you add, because you're like, oh, I forgot to add this tag, I forgot to add this security group, I forgot to add the CIDR block, and stuff. You forget about things. And the thing about most platform as a cloud services in the cloud is that I would say misconfigurations are even more important than a pen test. It's these things that you forget about and you don't configure them correctly, and you don't know about it, and that's where it really leaves you to be vulnerable. Which comes into infrastructure as code. This was the next evolution. It allowed you to have repeatable builds, automation, efficiency. You can put this into your pipeline, deploy your VPC, deploy your different resources, your databases, your applications, and just have everything be configured as code, and no more going into the AWS console, clicking on random buttons, and hoping that you clicked everything correctly. There were several iterations of infrastructure as code. A common one from AWS is CloudFormation. It's only on AWS. It's a native AWS service. If you have AWS support, they'll even help you with it. It's usually YAML format. It's also can be JSON. I've only really seen YAML in my professional experience just because it's easier to debug and comment out and iterate. But a huge downside was it wasn't really modularized, so you tend to not have dry code. You tend to repeat a lot of what you need to do. If you need like 5 EC2 instances or 5 databases and they're not all within an auto-scaling group, really what you're doing is you're copying the code and writing like your YAML is 5 times as large as it was before. Then there was Terraform, and then later OpenTofu. They're very related. OpenTofu was a fork of Terraform. This helped some of the dry components of code because you could actually do modules. You could modulize the code. It has its own DCL, HashiCorp configuration language. And this was a step up, but it was still because of the language constraints. You were limited in what you could do. Like it was a huge upgrade, but it was not perfect. Something that when you're looking at cloud controls, if we're going off a compliance benchmark, something we might want to look at is the CIS benchmark for AWS. Assuming you're in AWS, this talk is mostly for AWS, but you can apply this to other clouds. and I'll cover that a little bit later, but these are common things in the CIS benchmark in version 3, where You want all buckets to have access logging enabled. You want S3 buckets to all require SSL. And you want RDS instances to have encryption at rest. These are just like some standard stuff, best practices, and depending on your GRC policies, you probably want these enabled for every resource. Every bucket should have access, every bucket should have SSL, or all databases should have encryption at rest. But when you're helping developers, it's a lot like herding cats. A larger organization, people will be deploying resources, and you'll be like, okay, all S3 buckets must have SSL. You spend a little bit of time, and you're like, oh, somebody launched an S3 bucket, and it wasn't using our template. Oh, no, they launched another S3 bucket using the console. And then all of a sudden, you're managing, you were 100% compliant today. 6 hours later, you're not compliant. And this is at startups, which aren't very big. At an enterprise, large organizations, it becomes almost unwinnable. You need a solution where you can actually have the developers deploy secure constructs and take into account what they're doing. And this brings us to a cloud development kit, or CDK. It was created by AWS. It allows you to use a programming language like TypeScript, Python, Java. You can actually use JavaScript too. My preferred is TypeScript, just because the static typing is very useful for this. I think that it's lightweight enough that you can write code pretty quickly, but it will come down to your comfort level. And then there's also Terraform CDK. This is where most of the aspects of regular AWS CDK are applicable here. However, Terraform CDK, in my experience, it's not stable yet. It's still in beta. They say use it at your own risk. I've used it. I would not use it in production. This may change in the future. With Terraform CDK, you can probably do this to Azure, GCP, IBM Cloud, any cloud provider. But at the moment, I would say stick with AWS if you're using CDK. CDK has several command line arguments or command line commands. Bootstrap is how you set up a project. Deploy, destroy, pretty self-explanatory. Bring up the stacks, destroying the stacks. Synthesize is pretty interesting. So CDK compiles to CloudFormation. So with Synthesize, you actually turn it into CloudFormation templates. So you can write all your code as TypeScript, have all this logic, and have really robust validations, and then you can turn it into CloudFormation if you want it. Parts of a construct, so there's a scope. This determines what stack it's in, if it's a nested stack, where it is. It's usually this in JavaScript, TypeScript, self, and Python. By ID, this is a unique identifier. And then the props are really the arguments for a construct. So like if you look in CloudFormation, these are the properties that you're setting for the different platform as a service. When you're creating CDK constructs, actually just in cloud in general is how much access to give, because developers and engineers always want more access. They want to be able to deploy as much as they can. And as security professionals, we want to limit what they can do because we don't want an account to be compromised or privilege escalation or some sort of attack on credentials. There's multiple ways you can do this, but in AWS, one way to do this is to give them more access, give them the access that they want, or give them more access than you normally do, but then add service control policies or explicit denies. So they have an illusion of administrator access, but they don't actually have administrator access. So they say, oh, I have EC2 star. They do, but then we have an explicit deny elsewhere where they don't see, who actually denies all the stuff that we don't want them to do. It's a way to diplomatically give them access and at least make everyone happy initially. And also using a CNAP platform is pretty important, especially to look at IAM roles. There's a variety of platforms. There's even a vendor here, which is a CNAP platform. I highly recommend using a CNAP. But something that you need to look at when you're creating CDK constructs, and this will make more sense in the code, and I'll show some examples and I'll deploy, but it's how much documentation, how much self-service. So I've worked with multiple clients where they come up with these really abstract constructs. They're super secure, but they're not well documented, or they have to support them. So the more you deviate and actually make them more secure, more things that you change from default properties, the more documentation and more support you're going to have to do. Like I've seen enterprise clients where they have whole teams supporting, their custom code where there's documentation, and you could get AWS support or another type of enterprise support if they just left them alone. So knowing the needs of a business, how big you are, your budget, and knowing when to do this. And then I've also seen knowing how to throw exceptions. So a lot of clients say we don't want to block developers, we only want to give warnings when there's a misconfiguration. Like we want to make something like if a developer does not choose S3 buckets instead of SSL, then we just want them to have a warning. The problem with a warning is it doesn't give an error code. So in their pipeline, in their GitHub actions, they see a green check mark. Most people don't go into the logs and look for the little line that says warning. They tend to just say, this is good, let's keep going. And what happens is that you really didn't do anything. You just had this very small message in the code, and it just is obscure. I would always err on the side of throwing errors in this case. You want to break things when things aren't secure. You want to basically force developers to create secure code. You can also, if you want to, you could overwrite things in the code, and I'll show that briefly, where you can actually go in and say, hey, developer did not choose encryption, let's always force encryption. The downside of this is it comes back to maintainability. You create these values, you're forcing SSL, and then the developer said, hey, I spent like 4 hours, why is this value always changing when I deploy? Aspect-oriented programming is pretty useful, so I'm not sure how many of you are software engineers, but CDKs is all object-oriented programming, and you can use aspects to actually plot without modifying the existing code to add additional functionality or overwrite values, and I'll demonstrate this briefly. There's also, you can do full tests. The unit tests, you would use whatever testing framework you use locally to test, like JavaScript, you would use Mocha, Chai, etc. There's a variety of testing frameworks for each language. However, these are not comprehensive when testing locally. You really need to deploy the code, so you need to do some end-to-end integration tests, usually by deploying the stack and then testing there too. I'll cover a couple of the different resources before I go to the code. So just an example of EC2. EC2, for those of you not familiar, is just the standard VM in AWS, but you could have logic where you can actually change the SSH key. You could say only allow these SSH keys, only allow SSH keys with these values, or do not allow any EC2 instance to be launched with an SSH key. This is different than what you can do with Terraform or CloudFormation. You can use any, you can use regex expressions, you can do mix and match, you can basically put any type of code you want, and you just have a lot more robust and granularity with the details you can add to the code. You could go in and change CIDR blocks and say, do not allow port 22 with these CIDR blocks. If you do, throw an error in the code. And not that this is impossible with Terraform modules, but it would be a lot harder. It would be clunky, definitely clunky. IAM, what if you don't want these privilege escalation on IAM? What if you want to be able to have roles on EC2 not be able to have IAM pass role or create access key? You could say any IAM role with this trust policy to EC2, Lambda, etc. You could say throw an error if it contains any of these actions, or if it contains a star in any of these actions. So you can be very explicit in the control. API Gateway is another common service. So API Gateway is AWS's managed API Gateway, but it's usually not very secure by default. It's very hard to configure, but you could actually enable a lot of configuration. I'll demonstrate the code in a second. But you could say force authentication. Only authenticate with IAM or Cognito. Do not allow a exposed HTTP endpoint. Always put a web application firewall on it. Do not allow web WAFs or APIs without WAFs. Force logging to be turned on. Force cores to be turned on. Require SSL certificates. You don't have to do all of these, but if you're concerned about security, you're concerned about misconfigurations, you can mandate it. You can actually say, anytime somebody launches this, do not let them launch it. You're limited in service control policies because it's just JSON objects and you're limited in what you do. But if you give users explicit denies in the code, you can control this. And you can even do something similar in Kubernetes with EKS. There's manifest files, and I'll go over this in a second. But you could do something similar to Open Policy Agent in the code, and you can have granular control over the code. So let me go to the code. I have this CDK stack. I imported several CDK subjects. This is my vanilla S3 bucket. This is my secure S3 bucket. I have this inherent S3 bucket, and then I have this aspect that I'm applying. So vanilla S3 is very simple. This is all TypeScript. It's just an S3 bucket. We can see this is the scope. This is the stack. It's just the basic stack. This is the ID. And then props. I did not give it any props. If I go to bucket, we can see the different props which can be assigned to it. But I'm just giving it the default props. If I go to secure S3, I've now built on top of it, and I've added a KMS key. I'm saying whenever you create with secure S3 bucket, always give it the KMS key. We can even get more granular by controlling what's in the key, adding a variety of logic to say only allow certain access on the key, change the key policy. But I'm also enforcing SSL. I'm blocking public access. So now whenever somebody deploys this secure S3, it's a lot harder. It's a lot more secure. On top of that, we can actually do inheritance. So we can actually use this object and we can inherit from the AWS base S3. And we can go into the props and then we can overwrite them. We can put them in here. And we could even say, if this is undefined, throw an error. So if somebody tries to create an S3 bucket with blocked public access and they don't define a value, we can explicitly say, do not continue, stop this, do not deploy the stack. And this is a way where a developer could go in here, and if they didn't supply this name or didn't supply some of these values, it would just stop. It would just stop. Then we have aspects. And aspect-oriented programming, we can apply an aspect. So here, I'm looking to see if it's a S3 bucket, and if a website is false, and if it is, let's throw an error. So this way, if this value is website equals false, we could say throw an error, and let me just deploy. And you can see I actually deployed this a little bit earlier, but now we are explicitly throwing an error because it's not a website. But if we want to go to warning, we can deploy. And then all of a sudden, we just get warnings. We can say if we want to continue, I click yes. And down here, you can see there's different levels to the CloudFormation stack. I can actually specify, there's different levels of abstraction, but if I go to CNF, it's usually the CloudFormation resource. I can manually say, if version is not enabled, I can override it and turn on enabled. So these are just a couple of ways. This is a 20-minute talk, so I couldn't talk through every construct, so I could only really cover S3 in some detail. But it's really about maintainability and choosing like, you just have so much more control over making secure constructs by default, and you can then hand your developers some of this code. They just import it and say, don't use regular S3, use this secure S3. Use this S3 inherent S3. And then you should have security in default, and you spend less time going in and trying to manually change a bunch of resources that were created earlier. And then very briefly, I'll cover Cloud Security Matrix. This is from Cloud Security Alliance. It aligns with a variety of NIST controls, but if you're looking for a cloud security policy, that's something you can look at too. Yeah, well, SAM is built on top of CloudFormation. And serverless is built on top of CloudFormation too. They just have some abstraction and they have a bunch of plugins. So this would do, I would think this is a replacement for Terraform. There is, but of course, there's Terraform CDK, which is not ready yet. Don't use it quite yet. Use it when it's ready, but it's the same function. You can get the same functionality. When you deploy CDK, you get CloudFormation stacks similar to serverless. It manages state the same way as CloudFormation. I would say, like, there are reasons to use Terraform. There's a large ecosystem. There's OpenTofu, but it comes down.
Well, I found it has limitations, like you get into like real coding problems. So like, we've moved to a password vault, and I want to get rid of any secret in Terraform. So I got to pull from password vault, but it doesn't have, I mean, it does looping weird, it does, you know, lists and maps weird, like you got to do all this abstraction, whereas you know, you're writing everything in JavaScript or TypeScript or Python, you're just using the native.
Yeah, absolutely. Like there's stuff like that where Terraform sort of falls apart. Like
Right.
you're limited by the DSL. It gets really hacky.
The maturity level, I think,
Yeah.
with Terraform, and then you like,
Yeah, you can actually write actual applications, and you can actually package, you know, like your front end code with the infrastructure, all using the same language with same linters.
right.
It's just like you can add regular expressions. You can look through, and doing that in Terraform, I'm sure you can, but it's not recommended. And you can package Lambda functions up in here. I did not include that example, but you definitely can, and you can even write the Lambda function with the dependencies in CDK and bundle it up. So
You know, like,
with TypeScript is definitely the language I would prefer. It's strongly typed.
right.
And if you try to do this in JavaScript or Python, you're going to run into some strange errors, and you're not going to be able to figure them out without the typing system.
Okay.
So that would be my recommendation. Java would probably be fine too. I think Java it's a lot of code for what you're trying to do here, but it's definitely do what you're comfortable with. Yeah, in the AWS console under CloudFormation, there's some visualization for the stacks. So this compiles to CloudFormation. So anything that you can use with CloudFormation, you can visualize it that way too. So it's definitely possible. There's probably some open source projects too, but within the AWS console, they have a way where you can navigate and you can see, okay, with what resources were launched, how are they connected. I will say, my company, we resell CNAPs, and we resell multiple of them. So I do not want to give a vendor preference, but if you come talk to me after the talk and I can discuss. Okay.